We're still in Chapter 1. We're going to talk about Section 2, Observations, Measurement, and Variables. Constructs and operational definitions. Variables easy to measure might include height, a weight, reaction time scores, etc. A construct, which is an internal attribute or characteristics that cannot be directly observed but are useful for describing and explaining behavior. Example of a construct might be motivation, anxiety, hunger. It's internal. An operational definition of a construct identifies a measurement procedure, which is a set of operations, for how to measure external behavior in order to figure out what the construct would be. An example, self-esteem. We can measure it and we can operationally define it as your score on the Rosenberg self-esteem scale. Let's look at the difference between discrete and continuous variables. Discrete variables have separate, indivisible categories. No values can exist between the two neighboring categories. Example, the number of students in a class, a college major. Those are discrete variables. Another discrete variable might be the number of children you can have. You can have 1 or 2 or 3 or more, but you can't have half. You can't have fractions or decimals. Whereas on a continuous variable, there's an infinite number of possible values between any two observed values. Every interval is divisible into an infinite number of small fractional parts. Example, your height, your weight. Now we need to talk about how we do continuous measurement with real limits. Pay particular attention to this slide. When measuring weight to the nearest pound, let's say person A has a weight of 149.6 and person B has a weight of 150.3. We round them. We could say they both weigh 150 pounds. Okay? Why do we do that? Well, look at the number line, how we could do a number line. Let's do the number line at the top. It starts at 149, goes to 150, 151, and 152. But in actuality, when we're talking about 150, that is anywhere between 149.5 and 150.5. So the real limits for 150 are 149.5 as the lower real limit and 150.5 as the upper real limit. What if I asked you what are the lower and upper real limits for 152? Well, again on the number line, look at the one below. You can label it. The real limits would go from 151.5 to 152.5. If you had a weight anywhere between that, we would say you weigh 152 pounds. All right, let's look more at real limits. These are the boundaries of intervals for scores that are represented on a continuous number line. The real limit separating the two scores is located halfway between the scores. Every score has two real limits. The upper real limit is at the top of the interval. The lower real limit is at the bottom. So in the previous example, we saw that using whole numbers, that the real limits for 150 was 149.5 and 150.5. The upper limit is 150.5. The lower real limit is 149.5. Let's say we're measuring to the half inch. So then our number line would be in half inches. You would start with 59.5, 60, 60.5, 61. So in this case, what would the upper and lower real limits for 60.5 be? You would have to go halfway in between 60.0 and 60.5 to find the lower real limit. Think in quarters of dollars. So the lower real limit here would be 60.25. The upper real limit would be 60.75, or halfway between 60.5 and 61. Let's talk about scales of measurement. Measurement assigns individuals or events to categories. These categories could be names, such as male or female, employed or unemployed. They could be numerical values, such as 68 inches or 175 pounds. The complete set of categories makes up a scale of measurement. There are 4 scales of measurement that we will be using in this class. There are nominal scales. These are used as identifiers. There are ordinal scales. They carry information about order in a sequence. There are interval scales that show direction. They can include equal units between each interval. And there are ratio scales. They contain an absolute zero, meaning the complete absence of the measured attribute. Watch this video to help you learn more about the scales of measurement. Just click on the video. So let's look at a little bit more in depth and look at some examples. Nominal data. It's a label. It's how you're going to categorize. Nominal data might be gender. I'm going to say you're either male or female. Nominal data could be your favorite TV show. Could be your favorite flavor of ice cream. Ordinal data is something that has an order to it. Like, say, your clothing size, small, medium, large, extra large. Your rank in class. Ordinal could be first, second, or third place in a race. Ordinal could be your reading group you were in elementary school. Low group, medium group, or the high group. Interval scales, these have equal intervals, like temperature outside, an IQ score, a golf score. You're either 1 or 2 or 3 or 10 below par, or 1, 2, or 3 above par, interval scales. Ratio scales are the ones we use a lot in this class. There are equal intervals. There's an absolute zero, so 0 means 0 in a ratio scale. You can look at, for example, the number of correct answers. You can look at number of pizza slices that someone can eat. If you can make a ratio out of something, then it's going to be ratio data. For example, can I eat twice as many pizza slices as someone else? Yes, I can. Can I get twice as many correct answers as someone else on a test? Yes, I can. If you can answer that question, then it's going to be ratio data. Discrete variables have a separation between one value and the next. Discrete variables can be whole numbers. And nominal and ordinal data are discrete variables. Continuous variables with no separation can be expressed with decimals or fraction. And those scales would be interval and ratio. Those would consist of continuous variables. Let's look a little bit more at nominal data. It's used to identify. Nominal data might be your social security number, might be your student ID, maybe just your name. It could be your team, it could be the number on your jersey. It could be your room number. It's just nominal data. You can't add up and say that like people in room 64 have twice as good grades in people in room 32. Makes no sense. Nominal data you don't really do math with. In social sciences, race, gender, religion, occupation, these are all examples of nominal scales that we might use. Nominal scales allow us to figure out if measurements are the same or different. For example, if I said who likes strawberry, vanilla, or chocolate ice cream, and say 20 people liked vanilla the best, 15 liked chocolate the best, and 12 liked vanilla the best. It would be easy to do all that with nominal data. Let's look at ordinal data. Ordinal data is something in order. You might have seen these faces. If you go to the hospital, they might show you, instead of asking you, especially when you're younger, this is what they give children, pick the face. And that way they can turn ordinal data into numbers. So they're used as identifiers. They carry information about order. However, they don't convey information about distance between the variables. For example, you know that you can make an A, B, C, D, or F, and these are in order, right? But say you made 0 to 59 is an F, that's 60 points worth almost, 59 points worth that you get an F in a class. But there's only 10 points difference between a C and a D. So ordinal data doesn't mean anything about distance between the variables. A Likert scale is very common in ordinal data. Again, another example of a Likert scale is you may be chosen to ask on a scale of 1 to 5 how you feel. Very unhappy, somewhat neutral, somewhat happy, very happy. First, second, or third place, small, medium, large, all of this is ordinal data. Reading group, socioeconomic status, sizes, rankings. Interval data can be used as identifiers, show direction, and include equal units. Unlike ordinal scales, we can use interval scales to measure the amount of difference. We can do calculations of means and standard deviations. They require interval scales. 0 is a location and not a total absence. So for example, 0 means you're right at par in golf. You got the ball in the hole in the exact number of strokes that the course was built for. Some people can do better and they can do it in less strokes and they might have 1, 2, or 3 below par. Some people are terrible golfers or they just don't golf very often and they might get 3, 4, or 5 above par. In this case, 0 is just a location. It's not an absence of something. It just represents a location. You might also have seen interval data in terms of above and below average rainfall. The Weather Channels use this a lot. Ratio data is what we'll be using most in this class. Contains all the same information as the previous scales, but there's also an absolute 0. So if you have a height of 0 or a weight of 0, you don't exist, right? It's the absence of the attribute. Examples of ratio scales include income, height, weight, time, number of errors on a test. This allows for measurement of absolute values. You can measure from 0. All right, the rest is just learning checks. Pause the slides as needed and take time to work the problems and then come back and turn it back on and check your answers. Again, here's some more practice problems. Go ahead and work all 4 problems. Pause the video and then come back and start it again to check your answers.